The next genus of Enterobacteriaceae that we'll talk about is Salmonella. Salmonella has kind of a weird nomenclature. The majority of species that cause human disease, let me say that again. It's not the majority of species. The species that causes human disease is Salmonella enterica. But there are over 2,500 different serotypes. So when you talk about Salmonella typhi or typhimurium or whatever, you're actually talking about Salmonella enterica serotype or serovar typhi, typhimurium. And so the proper nomenclature would be the genus Salmonella, italicized like normal, but then the serovar will be non-italicized and will have a capital letter. That's one thing that sometimes I see students are not great with is how to properly write scientific species names. So this is the species. It's Salmonella, right, where the genus is capitalized, enterica, where the specific epithet is lowercase but still italicized. With Salmonella species, we would spell out the genus and list the serovar. So just like this. Salmonella species are really both species, the one that causes human disease and the one that causes animal disease, and all of the serovars associated, are really great at invading the host. So unlike E. coli, Salmonella tends to be fairly invasive, and it will actually invade the M cells that are found in pyre patches of the GALT, the gastrointestinal associated lymphoid tissue. They can replicate inside of host vacuoles, and most isolates or most serovars will have two pathogenicity islands. And so these are regions of the chromosome that encode genes important for pathogenesis or for causing disease. The first pathogenicity island encodes invasion proteins and a type 3 secretion system. The second pathogenicity island encodes proteins important for immune evasion and another type 3 secretion system. So with a Salmonella infection, here's just a Salmonella bacterium. It could be any one of the number of serovars. You have the invasion of the M cell. It'll translocate through that M cell into macrophages where it can survive and grow, which allows it to disseminate. They can also come in through other epithelial cells in the GI tract. So here's direct invasion of the epithelial cells. And they can be captured by dendritic cells, all of which allows them to go systemic. So Salmonella species are more likely to go systemic compared to like E. coli. They can colonize almost all animals. Some of the serovars are really highly adapted to humans, like Salmonella typhi and paratyphi. They can survive in the gallbladder and cause asymptomatic carriage. And so a patient usually will experience like the symptoms of the disease, the GI infection, and not even know that they're continuing to shed the bacteria in their feces because the bacteria are just living happily in the gallbladder. As you might imagine, and as with most of our Enterobacteriaceae, infection is as a result of ingestion of contaminated food or direct fecal oral spread. Some of the serovars have low infectious doses, just like that S-tech E. coli with the 100 bacteria can make somebody sick. Some have much higher infectious doses. A patient has to ingest anywhere from like 1 million to 100 million in order to get sick. The most common manifestation of Salmonella disease in the US is going to be gastrointestinal infection. Symptoms can develop anywhere from 6 to 48 hours after consumption. It depends on how much bacteria was consumed, how quickly it's able to colonize and replicate, and begin producing virulence factors. And for most patients, this will be a self-limiting infection where the symptoms will persist for 2 to 7 days. So you're going to be uncomfortable. It's not going to be pleasant, but it's going to get better for most patients. Some of the serovars, the ones listed here, are more prone to cause septicemia. And of course, patients who are immune compromised have a higher risk. More uncommon manifestations of Salmonella disease include enteric fever. So Salmonella typhi is associated with typhoid fever. Salmonella paratyphi, as you might imagine, can cause a milder form of typhoid fever. And this is because the cells are able to easily pass through the intestinal lining and replicate in other areas of the body. When you have bacteria that are replicating in other areas of the body, you will get symptoms like fever, headache, tiredness, loss of appetite. So it's called an enteric fever because the infection began in the gastrointestinal tract, and as the bacteria escaped the gastrointestinal tract, they replicated in other areas of the body. And chronic colonization, which is patients who have the bacteria for more than a year without symptoms of infection, develop in 1 to 5% of patients. It's kind of hard to put a number on this because if the patient has asymptomatic carriage, how do you know they're carrying it? How do you diagnose it? The gallbladder, as I mentioned before, is going to be the reservoir for most patients. And you may have heard of typhoid Mary. This is the classic example. It's real. It's a real life example of a patient who was an asymptomatic carrier of infection and was spreading it to other people. So this is a clinical study of a 25-year-old woman who was admitted to a hospital with persistent fever that did not respond to amoxicillin or acetaminophen or ibuprofen. She was a resident of the Philippines who'd been in the US for 11 days. She had a fever, an enlarged liver, abdominal pain, abnormal urine. Blood cultures were collected and were positive the next day for Salmonella typhi. So the majority of the Enterobacteriaceae grow pretty quickly. In laboratory settings, they can replicate every 15 to 20 minutes. So if you grow them on a plate, you see them the next day. The organism was susceptible to fluoroquinolones, so that was the drug of choice. Within 4 days, she had lost her fever and was discharged to return home to the Philippines. Although typhoid fever can be a very serious life-threatening infection, it can initially present with nonspecific symptoms as seen in this woman. So she had a fever, right? Lots of people get a fever. So that's a very nonspecific symptom. So it was lucky that they did the blood cultures and were able to identify the Salmonella. I told you typhoid Mary, she was a real person. She was a cook around the turn of the 1900s, like the 18 to 1900s. So around the turn of the 20th century. And she would work in houses and people in those houses would consistently get sick with typhoid and people would die. And then she would leave. And then the new house she would be working at, people would get sick of typhoid and then she would leave, and on and on and on. And eventually they kind of caught up with her and figured out that, hey, you're doing this to people. And at the time, they were able to basically arrest her. And they said, hey, you keep spreading Salmonella, like we're gonna, you can't do this anymore. And she said, okay, cool. I won't work as a cook anymore. If you let me go, I promise not to work as a cook anymore. And of course, that was a lie. So she just changed her name and continued to work as a cook, and everybody's getting sick and dying of typhoid. Eventually they pick her up again and, they're like, hey, you lied. And she was like, oh, my bad. And they said, well, we'll remove your gallbladder because that was the reservoir of the infection. And she said, no, I'd rather not. So they kind of kept her incarcerated basically forever. And she was like, hey, you all need a cook here? And they were, no. So it really is a real life example of that idea that a patient can have asymptomatic carriage and can continue to spread the infection. And because this is a fecal oral infection, that ought to tell you something about her own personal hygiene. And I'll just let you think about that. The other kind of famous example of Salmonella, and I believe this was Salmonella serovar typhimurium, it was only the second, well, it was the first time, but it's only the second example of bioterrorism in the United States. So the first example we talked about of bioterrorism in the US was anthrax that was mailed through the US postal system. This happened first, and it technically is bioterrorism. There was a cult in Oregon, and they wanted to control the local elections. I don't know. I mean, Oregon is a really cool place, but these weirdos really wanted to control this particular set of elections. And so they went to local restaurants and spread Salmonella typhimurium over, salad bars, salsa bars, they tried to make enough people sick that people wouldn't go vote so that only the cult members would vote, and then whatever the cult members wanted to vote for would win. It didn't really work out that way. Some people did get sick. Luckily, nobody died. But it is technically an example of bioterrorism because a biological agent was used to drive a political outcome. So very, very weird. We also do worry about drug-resistant salmonella in the US. So drug-resistant Salmonella typhi, estimated 4,100 infections per year, however, less than 5 deaths. We also see drug-resistant non-typhoidal salmonella, so some of the other serovars that combined can cause over 200,000 infections per year and about 70 deaths. I don't know if you're interested in birds. I like birds. Salmonella is really common associated with undercooked poultry or eggs, but it can also infect wild birds. So back in late 2020, early 2021, Salmonella was affecting a local finch species. And a lot of the birds died, and they're still seeing population effects of that. But the reason I bring it up is because there were also between 20 and 30 humans who got infections from the wild birds, some of whom were hospitalized. And luckily there were no deaths, but we still can see Salmonella infections from wild and domestic animals. So it's not only your food you have to worry about, it's also if you encounter animals that are sick.